Welcome to Byte Size Data Science. We continue to explore model characteristics with Eric Martens. This time, we talk about bias.
Hello, and thanks again to Jacques for having me on the channel to talk more about trusting the machine learning models you build. As I mentioned last time, being able to manipulate data and build good models is a critical part of a data scientist's job. But if they can't convince fellow data scientists and business users that the models can be trusted, then all that work will be for naught. In the previous video, I listed 3 vital components of a trusted model and discussed how we could use the Lime algorithm to explain individual model predictions. Today, I would like to talk about unfair bias. We'll look at what it is, some possible causes of it, ways to find it, and finally, some strategies for removing it. It's important to mention that we're trying to remove unfair bias from our models, since all models are biased to a certain extent. It's how they make their decisions. I also should point out that it's easiest to think of unfair bias in societal terms, biased against ethnic groups, ages, or genders. It's certainly been in the news a lot lately. However, machine learning models can be biased against any feature. We want to identify the ones that are affecting the model's predictions but should not be. Let's look at 2 examples of bias. In the first case, how about a model that predicts life expectancy for a company that sells life insurance? We know for a fact that women live longer than men on average for any number of reasons. Therefore, a model will be biased against males in the sense that it will predict shorter lifespans for males. In this case, this is not unfair bias. However, what about a model that attempts to screen resumes for job applications in the tech industry? In a well-known case, Amazon attempted to implement one of these, but found that it was assigning disproportionately low scores for female applicants, which is a textbook case of an unfairly biased model. But how was that unfair bias introduced? We can always start by looking at the training data. In some examples, there may simply not be enough training data for the model to gain an accurate picture of a certain group. For example, applying for home mortgages online is a relatively new phenomenon. A machine learning model meant to evaluate mortgage applications may not have enough ground truth historical data to accurately assess online applications, leading to potential unfair bias. In other situations, because our models rely on historical ground truth data, we can be training them to replicate past results. The old computer science axiom of garbage in, garbage out applies here, only modified to bias in, bias out. In the case of Amazon, their model was using resumes and application info from a traditionally male-dominated industry, and choosing characteristics that matched successful applications from the past that were primarily submitted by males. You might think, well, it should be as simple as removing gender as a feature of the model. Amazon tried this, but found that some of the other features of the model, such as language used in cover letters, schools attended, and more, correlated with gender and worked to introduce unfair bias, even though the model didn't know the gender of the applicant. There will be a link to this story in the description if you're interested in this fascinating case. So we know that we need to look out for bias, but how do we determine if our model is biased? We can use a measurement called disparate impact analysis. Disparate impact is simply the percentage of positive outcomes for the group we're monitoring, divided by the percentage of positive outcomes for the rest of the population. For example, if the model gives higher recommendations for 45% of our female candidates and higher recommendations for 55% of our male candidates, our fairness score is about 82%. The industry standard is 80%. If the fairness score falls beneath that, your model has issues with unfair bias. However, some industries, governments, or business best practices may require higher or lower fairness scores. So what happens if you've identified that your model is unfairly biased? What you do next depends on the source of the bias. If the feature can be reasonably removed from the model, start there. If it's a lack of training data, you can focus your data gathering efforts on a particular group to try and correct the bias that way. Finally, you could try modifying your input data slightly to try and reduce or remove the disparate impact. This can act as a sort of corrective lens for your model, improving the fairness score. Here, we're looking at an attempt to debias a model with Watson OpenScale, IBM's solution for monitoring machine learning fairness. In this example, the algorithm can successfully remove the bias without altering model accuracy. However, changing the data in this way can frequently impact model accuracy, as well as disparate impact scores for other monitored groups, so be sure to use it with caution. You can find more about that algorithm in the link below. In this video, we discussed unfair bias in machine learning models, what it is, some potential causes, how to calculate it, and even how it might be removed or at least mitigated. Please check out the description for the links I mentioned, as well as a link to the AI Fairness 360 Toolkit, an open source repo with more information and code samples. Thank you.
We now have a better idea about what bias is, how to detect it, and how to fix it. See you next time on Byte Size Data Science, and don't forget to subscribe.